In this lecture, we are going to look at the timers on the PIC 16F877. Let's begin by illustrating how a timer module operates. A timer module is basically a counter. It counts the number of pulses that are received by the module. The count value of the pulses is stored in a register that we shall call a timer register. In this case, the timer register is named TMR1, which is an acronym for timer 1. Let's suppose that at the start, the timer register contains an unknown value represented by XXXX. Before we start the timer running, we load it with a preset value. In this case, we've loaded TMR1 with the value FFFA. Once we start the timer running, the timer register is going to increment with each pulse that is going to be received. The first pulse results in the value in the timer register incrementing to FFFB. The second pulse results in incrementing to FFFC. The third pulse results in incrementing to FFFD. The fourth pulse results in incrementing to FFFE. The fifth pulse results in incrementing to FFFF. This value is the maximum value that can be accommodated in this timer register. When the counter receives a pulse after the timer register has reached its maximum value, an overflow is said to have occurred. An overflow causes the timer register value to go to 0 and an overflow flag to be raised. If configured, an overflow interrupt is generated. Generally, a timer module can operate in either the timing mode or the counting mode. In the timing mode, the timer counts the number of pulses that are received from the oscillator for the peak. In other words, the count value is a measure of the time period that the timer has been running. In the PIC 16F877, the clock frequency is divided by 4 to give a single counting pulse. In other words, the timer increments after every 4 clock cycles. In the counting mode, the timer counts the number of pulses that are received from an external source via a counter input pin. Prescalers and post-scalers are used to increase the counting range. A prescaler divides the signal frequency before inputting to the timer. As an illustration, if the prescale rate is 1 to 4, it means that the timer increments after 4 pulse inputs are received. A post-scaler divides the signal frequency after output from the timer. As an illustration, a post-scale rate of 1 to 8 means that the timer will overflow 8 times before the overflow flag is raised. The PIC 16F877 has 3 timers. These are named timer 0, timer 1, and timer 2. Timer 0 can operate either in the timing mode or in the counting mode. It is an 8-bit timer, meaning that it can count from 0 up to 255. In other words, the timer overflows when the timer register gets to the value 255. In hexadecimal, this value is FF. In counter mode, the source of the external count pulses is the pin T0CKI, which is multiplexed with the digital pin RA4. In counting mode, the timer is selectable to count on either the rising edge or the falling edge of the external count pulses. Timer 0 shares a prescaler with the watchdog timer. Timer 0 is associated with 3 SFRs. These are TMR0, which is used to hold the count value of the timer. Option range, which contains the bits that are used to control the operation of the timer. INTCON, which contains the interrupt enable and interrupt flag bits for timer 0 overflow interrupt. Let's look at the bits in the option register that are used to control the operation of timer 0. T0CS is the bit that is used to select between the timing mode and the counting mode of the timer. T0SE is the bit that is used to select between the rising edge and the falling edge in the counting mode. PSA is the bit that is used to assign the prescaler either to timer 0 or to the watchdog timer. The states to which these bits are set to select a particular case are as given in the notes. PS2, PS1, and PS0 are the bits that are used to define the prescale ratio. The prescale ratio is defined as shown in the table. For instance, if the bits PS2, PS1, and PS0 are set to 010, the prescale rate for the timer is 1 to 8, and the prescale rate for the watchdog timer is 1 to 4. If the bits are set to 101, the prescale rate for the timer is 1 to 64, and the prescale rate for the watchdog timer is 1 to 32. Timer 1 also operates in either the timing mode or the counting mode. It is a 16-bit timer, meaning that the timer overflows when the timer register value reaches the value FFFF in hexadecimal. In counter mode, the source of the external count pulses is the pin T1CKI. This pin is also multiplexed with other functionalities as indicated. In the counter mode, the timer only counts on the rising edge of the external pulses. Timer 1 can be turned on or off. This is unlike timer 0, which has no facility to be turned on or off. Timer 1 has a dedicated prescaler. Timer 1 has 5 associated SFRs. These are TMR1L and TMR1H that are used to hold the count value of the timer. TMR1L holds the lower byte, whilst TMR1H holds the higher byte. T1 con contains bits that are used to control the operation of the timer. PIE1 contains the interrupt enable bit for the timer overflow interrupt. PIR1 contains the interrupt flag for the timer overflow interrupt. Let's look at the bits in T1 con that are used to control the operation of the timer. TMR1 on is the bit that is used to turn on or off the timer. TMR1 CS is the bit that is used to select between the timing mode and the counting mode of the timer. T1 CKPS1 and T1 CKPS0 are the bits that are used to define the prescale ratio. The prescale ratio is defined as shown in the table. For instance, if the prescale bits are set to 10, the prescale ratio is 1 to 4. T1 sync is the bit that is used to enable synchronization. T1 OSCEN is the bit that is used to enable or disable the oscillator. Timer 2 is an 8-bit period timer. It only operates in the timing mode. In addition to the timer register, Timer 2 is an associated period register. The timer counts pulses as they are received from the oscillator until the value in the timer register matches the value in the period register. In other words, the timer overflows when the value in the timer register matches the value in the period register. On overflow, the timer resets to 0. Timer 2 can be turned on or off. Timer 2 has a dedicated prescaler and a dedicated postscaler. Timer 2 has 5 associated SFRs. These are TMR2, which is used to hold the count value of the timer. PR2, which is used as the period register to hold the period value. T2 con, which contains the bits that are used to control the operation of the timer. PIE1, which contains the interrupt enable bit for the timer's overflow interrupt. PIR1, which contains the interrupt flag for the timer's overflow interrupt. Let's look at the bits in T2 con that are used to control the operation of the timer. TMR2 on is the bit that is used to turn on or off the timer. T2CKPS1 and T2CKPS0 are the bits that are used to define the prescale ratio. T-out PS3 through to T-out PS0 are the bits that are used to define the post-scale ratio. The pre-scale and post-scale ratios are defined as according to the tables shown. For instance, if the post-scale bits are set to 0010, the post-scale ratio is 1 to 3. And if the pre-scale bits are set to 01, the pre-scale ratio is 1 to 4. Now, let's look at the bits that are used to control the overflow interrupts for the three timers. In INTCON, we have the global interrupt enable bit and the peripheral interrupt enable bit. These two bits are used to disable or enable all the interrupts and all the peripheral interrupts respectively. We also have the interrupt enable bit and the interrupt flag bit for timer 0 overflow interrupt. In the SFR PIE1, we've got the interrupt enable bits for timer 1 and timer 2 overflow interrupts. In PIR1, we've got the interrupt flags for timer 1 and timer 2 overflow interrupts. Running a timer is basically achieved by writing relevant values to SFRs and the bits associated with the timer. Here is a summary of the steps that are followed when running a timer. Number 1, select the clock source so as to configure the timer in the timing mode or in the counting mode. This is only applicable to timer 0 and timer 1. Number 2, select the clock edge when you are running in the counting mode. This is only applicable to timer 0. Number 3, set the pre-scale and post-scale values and assignments as relevant. Number 4, set synchronization and oscillator enable states. This only applies to timer 1. Number 5, set the period value by writing into the period register. This only applies to timer 2. Number 6, load the starting value into the timer registers. Number 7, enable the interrupts if you would require to use the interrupts. Number 8, put on the timer. This only applies to timer 1 and timer 2. Number 9, wait for overflow to occur. Alternatively, you can pull the timer flag to check whether an overflow has occurred or not. We have a tutorial exercise here. In the exercise, you are required to develop micro C program routines that can be used to configure and start the timers running as according to the requirements stated in the questions. Please attempt this exercise and optionally submit it via the Google Classroom. The submissions will be for me to check whether you have written the programs correctly. Here is a laboratory exercise. In this exercise, you are required to design a track speedometer based on the timer modules on the PIC 16F877. The comprehensive laboratory sheet shall be uploaded onto the Google Classroom. Please attempt this exercise. This laboratory is an extension to the previous laboratory exercise where you were designing a track speedometer. The extension requires you to add a functionality that enables the maximum speed that was reached by the track to be determined. Please attempt this exercise. After attempting this exercise, upload your complete response, that is the response for both the labs, onto the Google Classroom.